Welcome to The Tech Between Us, a podcast that takes a look at the past, present, and future of some of today's most influential technologies. Hi, I'm Raymond Yen, your host and director of technical content at Modar Electronics, a leading global distributor of semiconductors and electronic components. We've all seen it. Drivers texting, picking their favorite song from their personal audio system, it's not just a car radio anymore, or even almost nodding off after a long day. Most of us are probably guilty of these every once in a while. We've been told time and again how dangerous distracted driving is. We're all looking forward to the day that self-driving cars are finally here and we can nap or watch our favorite movie while on the way home. Well, that's level 5 autonomous driving, also known as full autonomy, and it's years away. We are only at the cusp of level 3 or conditional autonomy. At level 3, the driver must be able to immediately take control of the car if the conditions, hence a conditional autonomy, fall out of the range of the autonomous mode. The car itself needs to know that the driver is alert and not distracted and able to grab the wheel, so to speak, if needed. Unfortunately, according to Consumer Reports, research has shown that drivers are less likely to pay attention when using current automotive automation, such as adaptive cruise control and lane changing. Driver monitoring systems are required not only to sound an alarm of some kind to tell the driver to pay attention, but also to determine if it's safe to hand control back to the human without causing an accident. As the name suggests, DMS systems only look at the driver. What about the rest of the interior of the cabin? Can a similar system help us avoid the hundreds of heartbreaking scenes of infant death or injury from being left in a hot car? Or even something as innocuous as being able to stop the annoying alarm that's sounding because the car thinks my pizza order in the front seat is a passenger not wearing their seatbelt. To help us delve into the new driver and occupant monitoring systems, we have with us today Modar Alaoui, founder and CEO of Eyeris. Modar, thanks for being with us today on The Tech Between Us.
It's my pleasure. Thanks for having me.
Just briefly, can you tell us a little bit about yourself and what Eyeris does?
Yeah, so I've been involved in computer vision AI for just a little over a decade now. My academic training is in human behavior understanding, and that's from Concordia University in Montreal. I have always been kind of entrepreneurial spirited, with a big passion for cars and transportation in general. I also have a genuine motivation that's quite personal about automotive safety. So it kind of made perfect sense for me to start a human-centric vision AI company in the automotive space. Eyeris today is the leader, or one of the leaders. Eyeris today is the leader in what is known as in-cabin sensing AI. So understanding everything that happens inside vehicles in general, whether it's passenger or commercial vehicles, using a multitude of sensors, but most importantly, the primary sensor is image sensors now, and it's cameras. So naturally, as a computer vision AI company, we rely heavily on image sensors as the richest in order to receive. We rely heavily on image sensors in order to collect the richest source of information about what happens inside the cabin.
It's like you have the perfect job, basically combining your academic career along with all your passions. That's fantastic.
It really all kind of so happened serendipitously, so to speak. But of course, there's been a little bit of a prep work to this. So yeah, I wouldn't complain.
We've talked about how critical it is for autonomous driving. But, what exactly is driving, okay, pun intended, the need for driver monitoring? Is it, is it simply the car companies adding extra safety features? Is it regulatory? Or is it simply that the technology has finally matured for us to be able to do this effectively?
It's kind of a combination of all the things you mentioned. Number one, technology advances. Cars are basically the ultimate toy for consumers. And naturally, technology has been lacking in the automotive industry for a while, for a number of reasons. But now, with the advancement of AI and computation, it kind of made sense, and it's a natural transition for technology to kind of focus on automotive. There's also safety concerns. About 30,000 lives are lost globally due to car accidents per year, which is an astounding number. There's also focus that has shifted slightly from external perception for autonomous vehicles towards the in-cabin, simply because a lot of the companies involved in the autonomous vehicle industry, they realized that it's really hard or harder than expected, and therefore they started to look into what is the second domain, or what's the next logical domain where we could apply AI for automotive, where it could potentially be quicker and relatively easier to do. And so lastly, there is regulation pretty much everywhere in the world, but it's being spearheaded in Europe for driver monitoring, and now it is in place for model year 2025 and beyond. And it's every other region in the world is following suit. So the U.S. has legislations that are available now, or that have been presented, and so is the same thing for Asia, particularly Japan, Korea, and China.
Well, what you're saying is, literally for the 2025 year model, if a car doesn't have a driver monitoring system, it just can't be sold in Europe.
That's correct, partially. Similar to backup cameras regulations here in the U.S., there will be an incremental number of vehicles every year that has to have driver monitoring systems, or rather camera-based driver monitoring systems in Europe, and so that will go all the way up to 2030. So I'm not exactly sure of the numbers or the percentages, because those keep changing quite frequently. But the premise of this is basically a good percentage of vehicles, brand new vehicles sold in Europe, model 2025, will have to have driver monitoring systems that are based on image sensors or cameras. And so that percentage will continue to increase over the following 5 years until 100% of vehicles sold in Europe by 2030 or somewhere around that time frame will have to have a camera-based driver monitoring system.
So it's going to be phased in, but it's definitely by 2025 that is something that is clearly going to be a legislative target for Europe. And like you said, U.S., Asia, it's pretty much global. It's pretty much a global initiative.
That is correct. So obviously every large car manufacturer targets global markets, including Europe. And so if they are designing vehicles for 2025, then, and they know there is regulation in Europe, so clearly they will introduce some of these features in all of their vehicles throughout the world, regardless whether some of those markets have mandated the technology or not.
FACRA RF connectors from Molex offer a sealed inline solution for exterior automotive cameras, radio antenna, keyless entry, and any application requiring an IP69K rating. It uses a mechanical key feature and visual color code to differentiate between applications. Learn more at mauser.com/Molex. You'd mentioned that all these new laws are based on or talking about camera or vision-based systems. What sorts of hardware is going to be involved in? Obviously, there's going to be a camera, but what other sorts of hardware is going to be involved in actually using this camera and integrating it into a dash system of some kind?
There's this in-cabin sensing is not very much known to a lot of people, I guess, but it is a bit of an ecosystem. There are so many variables, so many components that are taken into consideration for this domain or square footage to be understood with the highest level of accuracy, if you would. And so the components are image sensors. Of course, you have lenses, active illumination components. You have processors. You have other peripherals, such as the cabling and things like that. And then of course you have the software that is the brain of the technology. Most importantly, the computation requirements have been advancing, luckily, lately. Especially when with the introduction of AI chips just over the last few years. However, what we find out is car companies today are still struggling between having a dedicated processor that is just for in-cabin sensing versus sharing resources, let's say with the infotainment processor or the head units or the ADAS processor. And so these are things that are still being figured out between the advanced engineers teams, the ADAS teams, and the rest of the engineers that are focused on the in-cabin sensing parts.
What you're saying is that, there are currently pretty powerful processors running the new infotainment systems. There's going to be, as ADAS becomes more and more autonomous, there's going to be powerful processors there. So the driver monitoring could piggyback on top of that, or like you said, have its own dedicated system. Is there a trend, or are you what are you guys seeing as far as trends? Are we leaning more towards dedicated or more towards integrated?
The trend is definitely leaning more towards a dedicated processor because it makes sense. As we provide as a software company, and all of the others in the in-cabin sensing industry, as there are more features presented to car companies for the in-cabin space, that requires naturally more processing power. And so it also requires new functional safety standards. And so the trend is, even from the chip manufacturers, they're dedicating time and resources into dedicated processors. And so this is kind of what we do expect in the near future. However, I would say there are still those traditional OEMs that are conscious about the pricing, but most importantly, wanted to, simplify their engineering processes, where they propose a shared resource with the head units or the ADAS or the infotainment. And so there's a bit of a battle within the engineering teams, as you could imagine, from within the OEMs and the tier ones alike.
Right. Yeah, I'm sure each of the teams is not wanting to give up any of their precious processing power for other systems, but, obviously all of them are going to be required.
That is correct. So we do make the case for dedicated chips, and of course we make suggestions for our partner companies, and we provide even some sort of reference designs for them, which cuts on their cost and development time, and in effort to advance the trend towards dedicated systems. Because at the end of the day, the AI advances at a much faster pace than processors, and we do present or offer or propose some future-proof processors that could potentially be good for the next 5 to 10 years, so to speak, with especially with the advancements of over-the-air updates. But at the end of the day, it is always up to the customer, and so we find ourselves, trying to navigate through these waters while preaching as much as possible for dedicated processors.
And something just, a thought just struck me. So, with the new driver monitoring systems, there's going to be, some sort of camera or vision-based system. What about privacy? Are there any concerns about privacy and having a camera pointed at the driver, every time they step behind the wheel?
Yeah, there will always be some concern with regards to privacy from a certain, group of consumers. I don't think that will ever change. The way these image sensors work today, they're not a recording device as, regular cameras that you would find in a supermarket or a bank or elsewhere. These are literally sensors that look at the environment and translate it into data immediately by shredding the image or the video. There's actually no recording that happens. There could potentially be a recording for events as needed, but at the end of the day, the consumer has always the choice to use some of these features if they wanted to or not. Tesla, for example, today and some other vehicles have a camera built into their vehicles. And they clearly state, would you like us to collect data in order to enhance some of our in-cabin features or not? And at the end of the day, the consumer always has a choice. The downside for them not using some of these features is that, of course, the vehicle will not potentially move from a level 1 to 2 or from level 2 to 3 and so forth, simply because the camera is not activated. And so, it's a double-edged sword for the consumer. But what's more important is these are sensors that no longer record video as most people were used to in the days when they hear about a camera inside a space.
I actually had never thought about that. It's a natural tendency, like you said, when people hear the word camera, they think recording device, whereas the cameras, quote, that you're talking about, like you said, are more sensing devices without the back-end recording part of it. And I think, and that to me is an important distinction between, kind of what you guys are doing in driver monitoring compared to, like you said, a bank or something like that.
That is correct. So initially when we started, and that dates back to, end of 2013, we were talking about cameras inside the cabin. And so that was received with a lot of both excitement, but also skepticism. Fast forward a couple of years later, OEMs and Tier 1s started to seriously think about this. And so, when car companies try to introduce a camera inside the vehicle, it's almost like we don't even have to talk about it. The end product here is the car, and the car manufacturer decides to put a camera in there. So we're kind of not even in the mix. Our software obviously abides by all privacy laws worldwide. And so that's kind of being bypassed for the most part now. And the benefits, really, Raymond, the benefits here far outweigh any privacy concerns, simply because we're focused here primarily on safety.
And like you mentioned earlier, the consumer can technically turn off some of these features, but at a cost of some of the more advanced autonomous features, like going from level 1 to 2 and 2 to 3, where some of the features of a driver monitoring system is absolutely required.
That is correct. So some of these features are enabling technologies, and therefore they could enable additional features where the vehicle becomes more and more automated in order to provide safety, comfort, and convenience to the consumer.
In the discussion here, the hardware is obviously advanced, but it seems like the software is going to be doing most of the heavy lifting in these systems. It's you've got a basic a processor, an image sensor, cabling and things like that. But, a lot of software sounds like it's going to be involved in a lot of machine learning. The Hayabusa image sensor platform from onsemi brings new levels of performance and image quality to ADAS and in-cabin applications, providing both viewing and sensing capabilities. And built on a common pixel architecture, Hayabusa image sensors reduce development time and effort across automotive imaging applications. Learn more at mauser.com/onsemi. Can you walk us through a little bit about some of the algorithms that you guys are using and that are going to be required for a driver monitoring system?
Yeah, so historically, companies started to look into driver monitoring systems in order to understand where the driver is looking at. And so they started looking into eye tracking companies. And so some of these companies were labeling themselves as eye tracking companies. Technically, when the use case kind of converged a little bit more towards, hey, can we do the eye tracking of the driver? Then, of course, everyone kind of shifted focus towards automotive, and therefore they became driver monitoring companies. But the software, like you mentioned, is actually the brain in all of this. So essentially, what the software does is it looks at the driver, whether they're present or not. Generally, it's the upper upper body, or the upper portion of the body. So the head, most importantly, looks at the head location. It basically understands where the facial features are. It tracks the face as well as the facial features in real time, actually multiple times up to 30 frames per second. And then it understands where the pupil is, whether the eyelids are open or not, whether the person is blinking or not, what's their head position. And then we go beyond the driver monitoring, where we understand, for example, upper body posture, orientation, upper body height, width, size, all the joints of the actual body, where the shoulders are relative to the elbows and relative to the wrists and things like that. And after that, we also look into other things that are complementary. Are there any objects within a scene? What is the driver doing? Is he paying attention or not? Are they doing a gesture they're not supposed to be doing? Are they engaged into a conversation? What is their emotional distraction look like? So we look at the entire in-cabin scene, which of course includes the driver primarily, but we do much more than just focusing on the driver, but rather the entire in-cabin space.
So obviously it's gone way beyond eye tracking, simple eye tracking and understanding where the driver is looking. I mean, the cameras now are able to paint an entire picture of, what the driver is doing, almost to the point where, what they're feeling and based on posture and things like that. So really, isn't it a fairly advanced portrait of the entire scene rather than just the eyes?
Oh, absolutely. In fact, when we initially started, there was a lot of noise around driver monitoring systems. And so we kind of had to focus on all the areas that were less understood at that time for a number of reasons. But then as we started recommending different camera positions, different field of views for the camera lenses and things like that, naturally, our customers started asking, can you also offer driver monitoring systems, but from this other location? And of course, we were able to provide them with, all the features that they were asking for, plus driver monitoring system. And so some of these features include body tracking, object recognition, hand gesture, hand understanding. And all of that was using only camera image sensors or cameras. And then just about 2 years ago, we introduced also what we call the world's first in-cabin sensor fusion AI, where we combine image sensors with radar and thermal imagers in order to understand the in-cabin space better and more accurately. Similar to external perception or, the autonomous vehicle trend today, it uses multiple sensors in order to understand the environment. We see a very natural transition today that will take place inside the cabin and will actually have multiple sensors combined or fused, if you would, in order to better understand the space, not just for the driver, but also for the passenger, the second row seats, the third row seats, and not only just for passenger vehicles, but also for commercial vehicles. And we believe that the applications are endless.
So you've gone beyond just, monitoring, the one person, that's behind the wheel, into, monitoring the occupants of the car, both in the front, passenger seat as well as the back seat. And you had even mentioned monitored looking at objects and the overall in-cabin space. What are, from an algorithmic and what the camera is looking for standpoint, what are the differences between what you're doing with the driver versus when you're doing occupant monitoring or as you put it, in-cabin monitoring?
So naturally, we look into the primary driver monitoring features such as, landmark tracking, head pose, eye gaze, percentage of eye closure. But then we go a little bit beyond that. We obviously provide ear localization. We provide face ID, the entire set of 7 emotions: drowsiness, fatigue, attention, distraction, gender and age group. And we do that not only with 2D, but in 3D, although we use 2D sensors. And so we call it monocular 3D DMS or advanced DMS, plus all of the other features for body, object, hand, gesture, etc. So we truly believe that the future for in-cabin sensing is 3D. The world actually, as we perceive it, is in 3D. And therefore, some of the R&D that we've started doing a little over 2 years now is particularly to solve this problem of using simple 2D image sensors, primarily RGB-IR sensors, but providing 3-dimensional information for our customers. And we truly believe that would be, or that is, the holy grail of understanding the in-cabin sensing space.
So you're able to take, with these 2D sensors and creating the 3D models, get an accurate picture of the overall in-cabin space, occupants, as well as, car surfaces, seats and things like that. When you look at the artificial intelligence or machine learning aspect of it, is it one gigantic model, or are you looking at multiple models of, one model for occupants, one model for surfaces? Or, how is the machine learning aspect of that looking?
That's a really great question. Ideally, everything needs to fit into one single model, except that different customers have different requirements and have different KPIs for production. And sometimes multiple models are the best way to go. And I say multiple, it doesn't necessarily mean they have to be 10 models at once, but maybe, 3 to 5, say, depending on the list of features, of course, that are being requested. And some other times, one single model makes perfect sense. And if you look at the state of the art today for AI, everything is based on deep learning. Deep learning today is primarily supervised learning, which requires annotation or manual labeling of the data. And of course, speaking of data, that requires, for models to learn, they require a significant amount of data sets. This is one of the things that we've initially started, or realized early on is, there is no publicly available data sets for the in-cabin. So we set out to collect what we believe today is the world's largest in-cabin data set from thousands of individuals that we hired for 1 to 2 hours at a time. They come into our labs and drive vehicles in, specialized tracks, or sit in a stationary vehicle and kind of simulate a driving experience. So all of that for the purpose of collecting as much information as possible from the driver and, of course, the passenger. And of course, the passengers, but also it is to enable as much as possible training one single model that understands multitude of things. And so the end goal is to have the least amount of models running in parallel but ideally one single model that can understand the entire in-cabin space.
So you guys have actually gone and created your own models just for the lack of a public data set or a standardized data set. The models that you've created, are you making those available to to others? Or it sounds like they're pretty extensive models.
Technically, we have generic models that we offer to most of our customers, and it doesn't mean those are the final models that they want to use for production. But of course, for production, things could potentially change from one vehicle to another, or from one camera location to another, and therefore we apply advanced machine learning techniques and transfer learning, basically, that allows us to customize our models for each individual customer, each individual vehicle, camera placements, field of view, image sensor, etc.
Once again, it sounds like you've gone kind of done this extra step and created your own models. And once again, it sounds like they're fairly robust models for the entire cabin.
That's right, and that's what we believe, and that's where we see the trend going forward. Everything needs to consolidate at the end of the day into one or the least amount of models in order to understand as much as possible about the in-cabin space.
And Modar, from what you've described, it sounds like you are going way beyond, what's required in legislation, the current legislation for camera and vision-based driver monitoring. Where do you guys see yourself? From a technology standpoint, after fulfilling all the requirements of legislation and the automobile, your end customers and whatnot. Where do you see this technology going?
Raymond, we look at this space as a virgin territory. It's the least understood space where the consumers spend a significant amount of time in. And so initially, when we started looking into what else we can do to understand the in-cabin space, what are the features, what are the use cases, we couldn't help but to think about what could the data do or enable from the in-cabin space. We truly believe that opportunities would basically become available for commerce companies that are outside of the vehicle space. We also think that this data could potentially be valuable to companies such as entertainment. This is the third living space after the homes and the offices for most consumers. So, how can, once safety is established or improved significantly, what else can be done? How can we improve comfort? How can we improve convenience? How can we connect this in-cabin space or these consumers to the world? And so we're literally just scratching the opportunities that understanding in-cabin, automotive in-cabin space can offer. And we're super excited about the future and what could this mean to future technologies and future use cases.
Absolutely, yeah. Because once you've solved the safety and the security aspect, it's a huge environment out there for the data for these types of systems.
Absolutely. We look at this as a mega trend, as a significantly enabling technology that would literally change the automotive industry and the way consumers use their vehicles as a whole.
Absolutely. And that whole industry is going through some major changes between autonomy and mobility as a service and now driver monitoring, in-cabin monitoring. Yeah, that's going to be, we're not going to recognize our cars, 10 years from now.
And that's the whole premise of AI. It's really enabling what I normally, talk about a lot and call ambient intelligence. It's actually removing that extra layer between technology or objects or devices and humans, where these machines could potentially become an extension of humans once the safety aspects are established.
So, Modar, I want to thank you so much for being with us on the Tech Between Us. Really interesting stuff on what's going on inside the car, and compared to, like you said, the focus has been previously on what's outside the car.
It is my pleasure, and thanks for having me, Raymond. Cheers.
Thank you so much. We hope you've enjoyed this episode of The Tech Between Us. Remember, this podcast is just one part of our original and ongoing content series, Empowering Innovation Together. You can find videos, articles, and more on driver monitoring systems at mauser.com/empowering-innovation. And don't forget to join us for our next episode when we talk private 5G networks.